Now that we're done weighting, let's get on to problem 91. Block A, with weight 3W, slides down an inclined plane S of slope angle 36.9 degrees at a constant speed, while plank B, with weight W, rests on top of A. The plank is attached by a cord to the wall. The first question asks us to draw a force diagram for block A. The second question asks us to assume the coefficient of kinetic friction is the same between A and B and S and A, and then use that to determine its value. Note, block A is at a constant velocity.
Without any friction, let's slide on over to our force diagram for A. Now, the first step we did here is we created an x' and y' axes. This will make the problem easier to solve. In the positive y' direction, the only force we have here is the normal force between A and S. In the positive x' direction, we have two forces. There is the kinetic friction between A and B, and the kinetic friction between A and S. In the negative y' direction, we have the normal force between A and B, and we also have the vertical component of the 3W weight. And in the negative x' direction, the only force we have is the horizontal component of the 3W weight.
Now to somersault our way into part B. The first thing we did was compile our known equations. We summed the forces in the y' direction acting on block A. Next, we summed the forces in the x' direction acting on block A. We also had the kinetic friction equations between A and B and A and S.
Next, we connected our kinetic friction equations with the equation we derived from summing the forces in the x' direction acting on A to form what we call our master equation.
Using our master equation and the equation we derived from summing the forces acting on A in the y' direction, we isolated the coefficient of kinetic friction to equal 3W sine of 36.9 degrees divided by 2 normal AB plus 3W cosine of 36.9 degrees.
Before we move on, we have to find what the normal force AB is, and to do this, we have to create another force diagram, this time for plank B. In the positive y' direction, the only force acting on B is the normal force AB. In the positive x' direction, the only force is the tension from the cord. In the negative y' direction, the only force is the vertical component from weight W. In the negative x' direction, there are two forces, the horizontal component from weight W and kinetic friction between A and B. Be careful! Weight is at a 36.9 degree angle from the negative y' direction. We forgot this on our first run through. It is very important to keep track of all the directions.
Using our force diagram for B, we were able to sum the forces in the y' direction acting on B. It is important to remember that the problem states that B is at rest, making its acceleration 0. We were then able to find that the normal force of AB is equal to W cosine of 36.9 degrees. Forcing this value into our master equation, we found that the coefficient of kinetic friction is equal to 3/5 tan 36.9 degrees, or 0.45.